Okay, so now we've got graphing a translation of a hyperbola. Okay, so we're on identifying and graphing translated conic sections, part 3. So the first one that we're going to do is example 4, graphing the equation of a translated hyperbola. So looking at this, we can tell that it's in hyperbola form based on the fact that we've got that minus sign in between the two terms. Okay, and this also tells us right away what kind of hyperbola we're going to have. We know that it's going to be horizontal. Okay, it's going to have a horizontal transverse axis because the x squared term is the positive term. Okay, so the x squared term is positive, so the transverse axis is horizontal. And a squared, remember the a squared term always comes first in a hyperbola. Okay, so the a squared term is 9. Okay, and the b squared term is 1. Well, you might ask, why do we know that the b squared term is 1? Because underneath the y squared term, we don't have a denominator, so the assumed denominator is 1. So because a squared is equal to 9, that means that a is equal to 3. And because b squared equals 1, b equals 1. Take the square root of both sides. Okay, the center is at h comma k. Well, it's written in the form x minus h, so that means that h is 1, comma, and y minus k, so that means that k is also 1. So our center is at 1, comma 1. So we will plot that over here. 1, comma 1 is the center. We will plot the vertices, a units to the right and left, so that would be 3 units. So you use a to determine how far over. So we count out 1, 2, 3 to the right, and 1, 2, 3 to the left. And so that means that our vertices are at -2, comma 1 and 4, comma 1. Okay. All right, so now to get the asymptotes, what we need to do is draw a rectangle that's centered at our center. Imagine that, 1, comma 1, okay, and is 2 times a. So, well, a is 3, so 2 times 3 is 6. So we know that the rectangle is going to be 6 units wide, which, if we look at our vertices, we already can tell that it's going to be 6 units wide. Okay, and then 2 times b, so 2 times 1 is 2, 2 units high. So I draw some boundaries there. Those are the boundaries for my rectangle. And then I just continue my rectangle here. I'm drawing it in purple to make it stand out a little bit. Okay, so there's the rectangle. Okay, and now the diagonals of the rectangle are your asymptotes. So I draw the diagonals through there. Okay, there's one. There's the other. Okay, we have our asymptotes, so then the last thing that we need to do is draw the hyperbola starting from each vertex and approaching, but don't touch the asymptotes. You don't want to touch your asymptotes. You just want to approach, but don't touch. Okay? Okay, so then the last thing to talk about is classifying conics if the graph is written in the form ax squared plus bxy plus cy squared plus dx plus e plus f equals 0. So we're talking about descending degree, so the highest degree in alphabetical order. So we have our x squared term, and then xy, y squared, x, y, and then our constant. Okay? And what we really care about here is the discriminant. So we really only care about a, b, and c. The d, e, and f really don't matter all that much. Okay, what we're concerned with in order to identify the conic is the discriminant, b squared minus 4ac. So if b squared minus 4ac is less than 0, and b is equal to 0 and a is equal to c, then it's a circle. If b squared minus 4ac is less than 0 and either b is not equal to 0 or a is not equal to 0, it's an ellipse. And if b squared minus 4az is equal to 0, it's a parabola. If b squared minus 4ac is greater than 0, it's a hyperbola. Okay. If b is equal to 0, that means that each axis of the conic is horizontal or vertical. If b is not equal to 0, then the axes are neither horizontal nor vertical. Okay. So example 5, classifying a conic. Okay, so we're given x squared plus y squared minus 2x plus 4y minus 11 equals 0. So we can tell looking at this that a is equal to 1, b is equal to 0. Why is b equal to 0? Well, we have no xy term, so therefore it must be that we have 0 xy. And it's just not written there because if the coefficient is 0, then we don't write that term. C is equal to 1, D is equal to negative 2, E is equal to 4, and F is equal to negative 11. And again, really don't care about D, E, and F, but we'll name them just for the sake of naming them. So we can tell A is equal to C, which is equal to 1, and B is equal to 0. So the value of the discriminant then would be b squared, which would be 0 squared, minus 4 times a, which is 1, times c, which is 1. So 0 squared is 0. 4 times 1 is 4. 0 minus 4 is negative 4. So that means that b squared minus 4ac is equal to negative 4. Negative 4 is less than 0. Okay, so less than 0 means that it's either a circle or an ellipse. And since we know that a is equal to c and b is equal to 0, the graph must be a circle. Okay, and that pretty much wraps it up for identifying and classifying conics and graphing translated conic sections. Thank you.